Okay. Anyway, let's say a little bit more. I just want to do a couple more examples about the Shapley Shubik, and then we can talk about the test. So last time at the end we did one example of the Shapley Shubik. I want to try one other just to refresh our memory, and then I got one for you all to try, and I want to make sure everybody is doing all right. So this is the Shapley Shubik. Something's weird with my scrolling. I'll deal with it. Let's just do an example. I hope you have a vague memory of what we did last time. If not, you'll remember right quick. How about this? This one was on the homework, 12, 8, 7, and 1. The homework from last time. Let's find the Shapley Shubik power index. Now, on the homework, I asked you to explain, and pretty much everybody explained correctly, that in this example, actually, the 8 and the 7 have equal power, and the 1 has no power. So when we do the Shapley Shubik, eventually the answer at the end should be the 8 and the 7 have like 50% of the power, and the 1 has 0%. That's the answer I'm looking for. Anyway, you give the voters names, and I'm always going to call them A, B, C. And then this is the way you do this is I'm going to make a big chart. First, I'm going to list out all the permutations, which I will call perms. That is just all the different ways that you could put ABC in some particular ordering. And there are 6 of them. You can go ABC or ACB. Those are the 2 ways to do it with A at the beginning. Or there are 2 ways starting with B. I could do BAC or BCA. And then 2 ways starting with C at the beginning. That could be CAB or CBA. All right. And when you're doing this, you gotta be sure that you don't forget any of them. There should be 6 of them when you're doing it with 3 voters. All right. And then I'm going to make another column, which is the weights in those particular orders. So the weight of A is 8, the weight of B is 7, and the weight of C is 1. So the weights for the first permutation would be 8, 7, 1. I'm just writing them in that order. This one is 8, 1, 7. This one is 7, 8, 1. This one is 7, 1, 8. CAB is 1, 8, 7, and CBA is 1, 7, 8. Right? This is not hard, really. It's just you have to think a little bit carefully. This is the hard step, such as it is, although still not really hard. But you have to decide in each row who is the pivotal voter, and what that means is you go across the list of weights and you add them up in your head as you go, and you decide which one is the one which actually causes the quota of 12 to be met. So in this row, I go 8 by itself does not make 12, but then 8 plus 7 does make 12, right? It makes 15, but that is 12. So 7 is the pivotal in that one, which is B. And you have to do this for each row. Add the numbers up and decide who's pivotal. Can anyone say in the next one, 8, 1, 7, which one is pivotal? 7. Yeah, 8 plus 1 is 9, which is not enough, so you got to go to the 7. In the next one, 7 and 8 will be pivotal. In the next one, 7 and 1 is not enough. I got to go to the 8. In the CAB line, 1 and 8 is only 9, so I got to go to the 7. And in the very last line, 1 and 7, 8 is the pivotal. All right? I hope everybody sees how I'm getting those. And so, which are they? That was B, B, A, B, A. Right? These are the pivotals each time. Yeah?
So if something's never pivotal, is that automatically no?
That's true. Yeah. Yeah, if you get somebody is never pivotal, it means their vote can never actually make the quota happen, which that's what it means to be a dummy. Yeah. Yeah. All right. So we're basically done here. There's just the last step is to just kind of summarize your results. And we do this using fractions, which if you want, you can convert to percentages. But the fractions each time is just the fraction of how many times is the A the pivotal? And the answer is 3 out of 6, right? There's 6 total scenarios, 6 total permutations. A is pivotal, 3 out of 6, which if you want as a percentage, that's 50%, right? Just because I know. 3 out of 6 is the same as 1/2, which is 50%. B is also 3 out of 6. 50% if you like. And then C is 0 out of 6, which is, of course, 0%. And that is the answer that I wanted. That's what I expected, right? I expected to determine that 8 and 7 have the same power and C has no power. All right? This is how we do the Shapley Shubik. On our test, for example, I would expect you to just leave it as the fractions. I mean, these I hope that you know 3 out of 6 is the same as 50%, but sometimes a fraction is weird, and I won't ask you to convert to percentage. If you had a calculator, you could do it, but you're not gonna. All right? Any questions about that one? Yeah.
Do you want us to simplify the fractions?
No, I don't care about that either. I mean, I know everybody knows 3 out of 6 is the same as 1/2, but yeah, I don't care about that. All right? I got one for you all to try. See what you think. Try. This would be a nice little practice for the test. You should expect to do one of these on the test. Probably not more than one. I mean, it'll take you a few minutes. One is enough, in my opinion. 12, 7, 6, 5. See what you think. I'm going to walk around and see how you feel. And I'm going to try to fix my screen. Feel free to chat with your friends about it. Looks like everybody's doing great. I'm going to write my my answers up here. All right, can we talk about it? This is the first few rows as I worked it out. As I was walking around, it seemed like everybody seemed to be doing great with this. If you do all of these, you actually get A as pivotal on all of these ones here. And so my final answer is A is 4 out of 6, B is 1 out of 6, C is 1 out of 6. All right? I hope that's as I walked around, it seemed like everybody was getting that. Anybody have any questions about this one? In my opinion, it's not hard to do. You do have to kind of think carefully when you're adding these numbers up. At least I do. But yeah.
Would it be okay if I put the fractions next to the numbers 6, 7, and 5? Because 6 gives 1/6 to the power.
Sure. Yeah. As long as I can figure out what you're talking about.
Oh.
Yeah. I don't really like when people. I would know what you mean, but like right here, I said A 4, 6. Sometimes I see people write things like, instead of A, the A is the 7, right? So they'll say like, oh, okay, my answer is 7 equals 4, 6, 6 equals 1/6, and 5 equals 1/6. I don't like that, because this is like, come on, man, 7 equals 4/6? No, like 7 is 7, and 4/6. This is just like, it's not true, is it? No, I have too much respect for the mathematical equal sign to write things like this, but I would know what you mean. Don't write that. 7 is not 4/6. 7 is 7, and 4/6 is a different number from 7. All right. Any other questions about that? This is not what you meant, I think. Great. That's the Shapley-Shubik. Can we say a few things about the Shapley-Shubik? So this is how you do it, right? One thing that I would like to talk about briefly is how many permutations are there going to be? So with 3 options, with 3 voters, as we've seen, there are 6 permutations, right? 6 different ways you can put 3 things in all various orderings. That's what the permutations is all about. What about if you had 4 different options? How many? Right, this would be, A, B, C, and D, say. How many possible ways of rearranging that is there? I would like to try and figure this out, not just by trying to write them all down and making sure we got them all and just counting them up, but can we think maybe a little bit abstractly to predict how many different possible ways of rearranging these there are? I want to think of this in terms of each rearrangement is some kind of like fill in the blanks. So each permutation is about filling in sort of, in the case of A, B, C, D, I have like 4 slots. And you can go A, B, C, D, or you could go A, C, B, D, or whatever. There's many different ways to do it. Each different way of doing it amounts to filling in the blanks in those 4 spots. And you're not allowed to reuse the same letter. You can't go like A. That doesn't make sense in this context. All right? Each permutation is about filling these in. And let's think about just like how many different ways possible are there to fill in the blanks here. And you could imagine this as being sort of choose them one at a time from left to right. Anybody want to say, how many choices do I have in choosing who's going to be first? Show me the fingers if you like. Everybody's saying 4. I think the answer is 4. Who's going to be first? It could be A or B or C or D, right? In the case when I'm talking about A, B, C, D. There are 4 choices to put in the first slot, all right? And now, given that you had 4, you put one thing in the first spot. Now, how many choices do I have for the second spot? There should be 3 choices remaining for the second spot because one of my options has already been assigned to the first spot. So I have 4 options here, right? I have 3 options here, 2 options here, and then only 1 option here, which is kind of like no choice at all, right? Whatever goes there, it has to go there. You're not even allowed to choose at that point. All right? So, for the entire thing, how many total different options are there? What should I do with those numbers? Should I add them all up? Or or what? Anybody have an idea about this? This is kind of like if I have 3 different shirts and 5 different pantses. How many different total outfits? Do I add those 2 numbers together? Which I don't think you should. That would be anybody think about pants and shirts all the time? I don't really, to be honest. My wife picks out her clothes the night before. I pick out my clothes like the moment before. What do you do with all those numbers? I think you don't add them. Because if I have, say, 3 different shirts and 5 different pairs of pants, how many different, I don't have like 8 total different combinations. There's more than that. Any other ideas? Yeah, you should multiply them in this case, right? If you have a bunch of independent choices, this is actually like a basic sort of principle. If I have, how about if I make 2 independent choices? Now in this case I'm making actually 4 different choices, but the same is true of any number. If I make 2 independent choices with, let's say, X different ways to choose the first one, and let's say Y different ways to choose the second one, then how many total different ways are there to choose? It's X times Y. It's not X plus Y. It's X times Y. So then the total number of ways to choose is X times Y. All right? This is like a basic mathematical fact about, really this discipline of mathematics is called combinatorics. It's all about, it's a mathematical subject based on counting up different ways of combining things, that kind of thing is what combinatorics is all about. All right, anyway, the moral of the story for this whole thing is, how many ways are there to rearrange 4 things? It's 4 times 3 times 2 times 1. You have to multiply all of those numbers together. So, for permutations of 4 things, right? You have 4 things to choose from, and the number of choices you have is 4, and then 3, and then 2, and then 1. There are 4 times 3 times 2 times 1. This, if you multiply that, is 24 possibilities. All right, 24 different possibilities. Yeah?
Oh, yeah, we're going to have to like work with that.
Yeah, you should find yourself wondering about now, am I really going to have to do a Shapley Shubik with 4 options then? Because then you have to make the big chart with 24 different rows on it. And the short answer is, no, I'm not going to make you do that. Although, I hope that you feel like you could do that if you really had to. It's not any harder. It's just like 4 times longer than the other examples that we've done. All right? So, anyway, for permutations of 4 things, there are 24 possibilities. In general, if I want permutations is something that's going to come up in other contexts during the class, which is why I want to talk about it just a little bit here. For permutations of, let's say, n things, there are. How do you do that? It would be, if you notice, this is what you get. This number 24 comes from multiplying up all the numbers. I don't know if you ever did this on your calculator when you were a kid. See, 1 times 2 times 3 times 4, you just keep on doing that. So if you have 4 things, you go up to 4. If you have n things, then it would be 1 times 2 times 3 times 4 times, etc., until you get to n, right? Whatever that is. There are this many permutations. Actually, there's a mathematical symbol for that. Has anybody seen this before? It has a name. Yeah.
Is it an exclamation?
Yeah, we write this. This is written as N. It sounds like you're yelling. It's the exclamation point is the operation. And that, do you know the name of that? It has a name.
Factorial?
Yeah, this is called the factorial. So this is called N factorial. And it means you multiply up all the numbers from 1 to n. That's called n factorial. Your calculator doesn't typically have a factorial button on it just because you might as well just, you can just type in multiplying the numbers. And the factorial numbers are very, very big. If you try to do like 100 factorial, this is probably larger than your calculator can handle. Just because it's a really big number when you multiply together all the numbers from 1 up to 100. All right, that's called factorial. So 4 factorial, this means 1 times 2 times 3 times 4, right? Which we just said before, that's 24. 3 factorial is 1 times 2 times 3, which is 6. That's why for three options, A, B, C, that's why you get 6 of them, because 6 is 3 factorial. 5 factorial, if you ever had to do the Shapley Shubik with 5 different options, this is 120, which we will definitely never do one like that. But these factorial numbers, they get super big really fast, all right? I will just say n factorial is super big when n is big.
It's
Yes?
written with the exclamation point. The n factorial.
Yeah, n factorial means that's what this exclamation point means.
Okay.
Yeah. All right. I thought I'd share with you this. We are not going to use this fact, but this is one of my favorite math facts. Favorite? It's not my favorite. One of my favorite. There's a formula that somebody figured out for figuring out what n factorial is. Like for a really big number, n factorial is super big, like 100 factorial. And this was actually, somebody worked this out around the year 1700. This is called Stirling's formula. Long before the days of calculators, there really was no good way to figure out what these factorials, how big are they? You could say it's going to be really big, but exactly how big is it without any kind of computing machinery? Your best bet is just you got to multiply all the numbers up to 100 or something like that, which nobody really wants to do. There's this guy Stirling came up with what we now call Stirling's formula. It says this, for large n, when the n is really big, it's an approximation for n factorial. What I like about this, why it's one of my favorite math facts, is that what I'm about to write is approximately equal to n factorial is totally crazy, and it doesn't seem to have anything to do with, it shouldn't have anything to do with factorial. It's all about multiplying 1 times 2 times 3. Anyway, this is Stirling's formula. Check it out. Were you expecting it to have a square root in it? It has a square root in it. It's the square root of 2 pi times n to the power n divided by e to the power n, where e is a number from calculus. This is the kind of thing that mathematicians really like formulas like this, because it takes, just think about, the thing on the left-hand side is just 1 times 2 times 3, etc. It's a really big number, but it's fairly ordinary, like you just get it by multiplying whole numbers times each other. Whereas the right-hand side, to me, looks ridiculous. I mean, it has a pi in it and a square root, but it turns out these two things are actually very closely related. Strange but true fact about factorials. My favorite thing about factorials. All right. Okay, I got one more thing to say about the Shapley Shubik, and then we'll talk about the exam. Any questions about Stirling's formula? I would not expect you to have it memorized. I don't have it memorized. It's a fun fact about factorial. So, okay, let's talk about some facts about Shapley Shubik. I just want to talk about something actually that somebody mentioned a few moments ago. I want to think about what happens if you are doing the Shapley-Shubik, like if there's a dictator or if there's a dummy, can we predict what their values ought to be when you do the Shapley-Shubik? And somebody said before, and this is one of the true facts that I was going to say, if, let's say, X is one of my voters, and if X is a dummy, what will their Shapley-Shubik score be as a percentage? It'll be 0, yeah. The Shapley-Shubik, the whole point of that is to measure how powerful each of the people are. And if it's a dummy means they have no power at all. Can we say why, how do you know that the Shapley-Shubik will always give you 0? It's because if somebody is a dummy, it means they can never be the one who casts the winning vote, right? They can never be pivotal. So I'm going to say if X is a dummy, then X is never pivotal, right? That's because a dummy is not capable of ever influencing the outcome. And so in particular, they cannot ever, when you do that chart, you're never going to circle the dummy because they are never the ones who make the difference, right? So then the X is never pivotal. So when you do their Shapley-Shubik as a fraction is 0 over whatever, right? When there are 3 options, it's 0 over 6. When there's 4 options, it'd be 0 over 24. Whatever the denominator is, it's a 0 on the top, which as a percentage is 0%. Remember, a fraction with a 0 on the top is equal to 0. All right, so if X is a dummy, then the Shapley-Shubik is going to be 0. All right? Any thoughts about that? I think this is pretty intuitive. What about a dictator? Then, what do you think? What's the Shapley-Shubik going to end up being for a dictator? Yeah, somebody said 100%. I agree. The dictator, the whole point of a dictator is they have all the power and nobody else has any power. Now, how can we be sure in terms of the pivotal? Well, I think if X is a dictator, then X is always the pivotal voter, right? In any combination, if you have a dictator, it's not possible for anybody else to be pivotal. The dictator is the only one who can be pivotal. And so if X is a dictator, then X is always the pivotal voter. And so their Shapley-Shubik is 100%, right? As a fraction, it would be the numerator is equal to the denominator, which is 100%. All right. And what about veto power? Actually, this is harder to say. So I'm just going to say if X has veto power, I will just say harder to say. It's a little more complicated, but in case you're wondering, it's not so bad. If we had more time, I would have a little discussion about this. But if X has veto power, harder to say, but I'll just say it turns out the Shapley-Shubik will be at least 1 over n, where n is the number of voters. So if there's 3 voters, say, and one of them has veto power, their Shapley-Shubik will end up being at least 1/4 or 25%. This is a true fact. A veto power person is never going to be 0%. It's possible. In theory, it could be much more than 1 over n because a veto power person could be a dictator also. But this is the fact about veto powers and the Shapley-Shubik. All right, and that's about all I want to say before talking about review for the test. Are there any last questions about the Shapley-Shubik? No. All right, great. Let's talk about the test then. So I have a review sheet here that I will hand out, and then we could start by just sort of simple questions. You know, what's going to be on the test is everything that we've ever talked about, including the stuff that we did today. There will be one more homework assignment due as usual on Wednesday. If you want, just to give you some more practice with the newer material before you see it on the test. This sheet that I'm handing out now, I'm also going to post on our class website in case you lose it or whatever. You have friends who aren't here. Went home early for the break? Come on now. Those people aren't your friends. Everybody always asks me, like, how many questions are going to be on the test? And my answer is, I don't really know. And but you should expect it to be, like, the format of the questions at least will be just like our quiz questions. No multiple choice or any of that kind of stuff. Just, I write the questions, you write the answers. I am going to print out the test and, like, hand it out to everybody, so you're not going to have to read the questions off the screen. But I will expect you to submit the answers on Gradescope like we usually do. So it should be something like, the quizzes have 2 questions. You should expect like 8 to 10 questions on the test or something like that. It takes up the whole class period. It is not my intention really ever to like make you do this stuff really fast. So I'm not going to try to like pack the test full of a lot of questions. Although you should expect, a question or so on each of our major topics. There probably will be a Shapley Shubik on there. Any vague questions about the test? If not, we can talk about specific topics. But anybody? No. All right. Great. So you can see here on the front are just like my list of topics and some specific sample questions. Some are not. But it is, the 2 major things are the ranked voting and the weighted voting. The ranked voting, you should know how to do these like 5 different methods that we've talked about: the plurality, Borda, Condorcet, ranked choice, and the dictatorship. There's also the approval voting and the random dictator, which are a little sort of weird, so they don't fit nicely into those charts. But I will leave it to you to figure out the answer, like for number 1 there. I put the answers on the back. You can check it out. Check yourself before you wreck yourself. It says, be familiar with the big chart. Why? That's what I mean about the various criteria with the checks and the X's on it. I wouldn't say you should have that memorized, but you should be able to tell me. I could ask you about any particular one of those. Tell me why ranked choice satisfies the majority or whatever. You should be able to. I won't expect you to have that memorized, but you should be able to give me a little explanation. Yes.
For like the 5 like different types of like voting, do you want us to write like imagine X blah blah blah, so blah blah blah, then blah blah blah? Do you want us to write that on the test?
Yes. That's the way that you would answer if I said something like, explain why ranked choice
Like it
satisfies the
satisfies,
majority.
okay.
Yeah. You would have to write some words like that. I mean, you don't have to say it exactly the way that I say it, but yes, you should say it something like that. All right. So you can see about the weighted voting questions like the ones on the homework that was due. The homework that will be due next week is all about Domies, Dictators, Veto Power, and Shapley Shubik. One thing that I wanted to discuss in particular was the IIA, because a lot of people did this wrong on the homework. It was on the quiz today, but that one on the quiz was actually kind of an easy example. I want to I will just refresh our memory about that one that was on the homework. It says this. By the way, I hope that you do each week go and look at your graded homework assignment. I always post the graded assignments before the quiz happens, so you should be able to check it out. Make sure you did everything correctly and see my comments if you didn't do it correctly. The IIA on the homework, a lot of people messed it up, so I thought it would be worth discussing. On the quiz, hopefully it went well. The quiz example was easier than this one, which was on the homework. So this one said, explain why, using this chart here, explain why plurality does not satisfy IIA. All right, so what you do, just like you hopefully did on the quiz, first of all, think about, sorry, I'm scrolled. Think about who is the original winner with this election, using plurality, it is A, because there are four, A has 4 votes in the top position, and nobody else has that many. So I like to kind of circle the winner, just to remind myself, when you're doing IIA, and your goal is to make a change in these votes in a way which actually changes the results of the election, but you can't change it however you want. This is, a lot of people on the homework were like, oh yeah, I can change it by moving this B to the top, all right? Some people said, I want to move this B to the top. This is a bogus answer, because the point of the IIA is you can change the winner even if you don't move anybody past the original winner. That's why it's called irrelevant alternatives. This change here is not an irrelevant alternative. This actually is, I mean, A was the winner, and you move somebody above the old winner, you should expect, yeah, that's probably going to change the answer. If I move somebody above the old winner, I'm giving somebody else more votes than they used to have relative to the winner. That's not allowed. You can't do that kind of change. You have to make a change which does not move anybody past the winner. You can't move someone who used to be below the winner above the winner. All right, so I'm gonna write that down, because I mean we wrote this down when we talked about IA originally, but it says, some people I think forgot the details here. It says if X is the winner and we make a change. There are various ways you can say this. You could say you make a change in a way which does not change anybody's ranking relative to the winner. This is a little confusing. Another way to say that is we make a change which doesn't move anyone past the winner. Then X should still win. This is the IIA criterion. If X was going to win, and then we make some change which doesn't actually move anybody up past X, you're just rearranging people on their own without moving them past the winner, then the winner should stay unchanged. All right? So the correct answer to this question from the homework, does anybody see how you could do it? So you are not allowed to move one of these guys up above the A. That's the thing. A lot of people said that. And then I can make B win by pushing B up, but that's not allowed in the IIA. Anybody see how to change the result? Actually, there is no way to make B win here in an IIA sort of way. Yeah?
In the last column, you could switch D and C.
Yes, in the last column, I can push C to the top. This does not move anyone past the winner, but it causes C to become the winner of the election, because C will now have 3 plus 2 is 5 points on top. So the correct answer to this question is, I'm just going to squeeze it in here so I don't have to scroll. Change D, E, C, A, B to put C on the top. I don't care what you do with the other ones. C, E, D, A, B. The point is, the winner, A, stays where it was, and you don't move anybody past the winner. All I did was rearranging the ones who were already above the winner. All right? This is what the IIA is all about. Anybody have questions about that? I hope that this is clear. Like I said, I don't know about most people. A lot of people mess this up on the homework. All right. This is all of like my agenda. This I identified as something we better talk about. But otherwise, we can talk about whatever you like. Anybody want to do? We could do specific examples of anything, any of these topics. Yeah.
Random dictator.
Yes. You want?
Can you do one example?
Sure.
It wasn't the homework one. But...
Yeah, there was one question about the random dictator, right?
Yeah.
Yeah. Yeah. So actually there were kind of two. One is I might ask you some kind of a vague question about kind of what the random dictator method is good for, and your answer should be something like random dictator is good for repeated low stakes decisions I say low stakes because you are using randomness, and most people in the real world don't want to decide important things based on random factors. And so in order to do this in a real world, for people to be happy with you, it probably should be individual low stakes decisions. Repeated is important. That is because in order for the probabilities to work out correctly in the long run, like, flipping a coin is 50-50% heads or tails, but that's only true if you do it a lot of times. If you only do it 2 or 3 times, then maybe you're going to get results that are very different from the 50-50. So repeated low stakes decisions is what we're looking for here. Some people on the homework, one of the homework questions was just make up an example where you think the random dictator would be a good idea. A lot of people didn't really have the repeated thing. I would be looking for something which happens over and over again and is low stakes. As for particular examples, we could say look at the one that you see on the paper there. I could ask you. I probably wouldn't in this particular example, but I could ask you. Tell me what are the chances of each of these candidates winning? So the chart on the paper says 3 people said ABC, 2 said CBA, 2 said BAC, and 2 said CB. What? That's stupid. I wrote the same thing in 2 different columns. This is a typo. I didn't mean to do that. Although it doesn't really matter. I mean, it's still a valid example. Sorry about that. I don't know why I did that. I put CBA in 2 different columns. It doesn't matter. Anyway, what are the various probabilities of each one of these candidates winning? So A wins with probability. Now this, I wouldn't give you this one exactly on the test just because the percentages are weird here. You have 9 total options here, and if you choose at random, A will be the winner 3 out of 9 times, right? Because there are 9 total ballots that are thrown in the hat, and 3 of them have A on the top. So in this case, A wins with probability 3 out of 9, which is a weird percentage. If I were going to ask you this question on the test, I would probably make it so that there's 10 votes here or 100 votes, so that it would be easy for you to tell what the percentage would be. But anyway, this is what A. How about B? What do you say? 2 out of 9? Yeah, because 2 of these ballots have B on top. And C? What do you say? 4 out of 9. Yeah. This is really all I would be comfortable asking about. This class is not a probability class, and we haven't. I don't want to focus too much on this kind of probabilities, but I would consider this to be something that you should all be able to do. Sound good? Any other thoughts about random dictator? Yeah, or something
no,
else.
But,
okay, yeah.
Can we do another example of
The Shapley Shubik?
Shapley, yeah.
You want to try another one?
Yeah, can we do another example?
Sure. That was what we did at the beginning today. How about I will just try to invent one. I don't know how interesting these numbers will be, but let's say 10, 6, 5, and 4. Let's see what happens. This is the one where you write down all the permutations. So I'm going to write, as always, I call them ABC. There will be 6 different orderings here. Make sure you get them all. I try to write them. My system for making sure I get them all is just, there's always 2 that start with A, there's 2 that start with B, and there's 2 that start with C. CBA. All right, and then those are the permutations. Now I'm going to write down the weights in those particular orders. So ABC goes 6, 5, 4. ACB goes 6, 4, 5. BAC is 5, 6, 4. BCA is 5, 4, 6. CAB is 4, 6, 5. And CBA is 4, 5, 6. All right? And now each time we choose the pivotal. So that is, you go across and add as you go, and you identify which one is the one which made it go, which made it equal or exceed the quota, which is 10. So 5 is the pivotal here because 6 by itself is less than 10, but 6 plus 5 is 11. So 5 is the pivotal here. I would say 4 is the pivotal in the next one because 6 plus 4 is 10 on the nose. Next, 5 and 6. 6 is the pivotal. The next one, 5 and 4 makes 9, which is not enough, so we go to the 6. The next one, 4 and 6 is 10, so 6 is there. And the last one, 4 and 5 is 9, so I have to go to the 6 like that. And so my answer would be A is 4 out of 6, B 1 out of 6, C 1 out of 6. All right? That's how we do the Shapley Shubik. It's a pretty nice, I kind of like the Shapley Shubik. It's kind of a pain to do it, but I find it satisfying to actually have a number associated with each of these guys. So I can say for sure A is the most powerful, B and C are equal. When just looking at the numbers, that's not obvious that that's the case, but it is the case. What else can we talk about? How about in this one? Can we talk about the dummies, dictators, and veto power? Show me the thumbs. Is there a dictator here? Yes or no? No, nobody's showing the thumbs. Everybody's shaking their heads. You don't have to do the thumbs if you don't want to. There's no dictator. Remember, dictator is easily identifiable. It just means one of the numbers is already meeting the quota by itself, and that's not true here. So no dictator, no dict. What about dummies? Is there a dummy here? No, actually you can tell from the Shapley Shubik. We didn't get 0 for any of them, so nobody is a dummy. There are situations in which even the 4 is relevant, so no dummy. Is there anyone with veto power? Remember, that means one of these which is always necessary in order to get to 10. Is there such a thing? Somebody, I see some nods. Who is it?
6.
Yeah, the 6 here has veto power. Because the only way to make 10 is if you use the 6. Because if you don't use the 6, the others can only add up to 9. So the 6 is necessary in order to get to 10.